Okay, so we're going to finish off this section of notes. So we want to restate the question here. F prime of x will go from being above to below the x-axis, which above means it's positive, and when it's below, that means it's negative. At any spots where f of x has a relative maximum, because that means if the derivative is switching from positive to negative, the function has switched from increasing to decreasing. So that's going to be here at -4 and again at 5. Because f of x has a relative maximum. All right, now we're going to do the opposite thing. We're going to look at the derivative. So this is a graph of f prime, and we're going to answer some questions about f prime, but also f. Okay, so just to keep in mind, anywhere that f prime is positive, f is increasing. Anywhere f prime is negative, f is decreasing. So on what open intervals is the graph of f of x increasing? Justify your reasoning. So you're going to say f of x is increasing, and it will be any time the derivative is above the x-axis. So because the derivative is positive. So that looks like the only spot is right there. So that's from -infinity until 2. And these intervals are always open because at 2 it's not increasing anymore. All right, so we'll say it's increasing on the interval -infinity to -2. So that is, oh wait, there's not an arrow there. Sorry, this graph starts at -3. So we're going to say -3 to -2. So I restated the problem. I answered it because f prime of x is above the x-axis, which means it's positive. Right? Or I could say because f prime of x is bigger than 0. Those are all ways to say it's positive, above the x-axis, bigger than 0. All means the same kind of thing. Okay, on what open interval is the graph of f of x decreasing? So I restate f of x is decreasing on, and then I have to go find those intervals, and we're going to say it's from -2 to 2, union 2 to 4, because, let's do these, let me erase this, because the derivative, or f prime, is below the x-axis or is negative on those intervals. Now I have to break it at 2, because right at 2 it is 0, it is not negative. So notice I broke it at 2. So this interval is the same interval as -2 to 4, except it does not include 2. Like I have to take 2 out of there. Okay, so that's the way you can write like that whole interval, but just not including 2. And again, I could say because that's where f prime of x is less than 0, which means negative. Or I could say is below the x-axis, which also means another way to say it's negative. So f is decreasing when f prime is less than 0. At what values of x does the graph have a horizontal tangent? Justify your answer. So we're going to say f of x has a horizontal tangent at, and it's going to be at certain x values. It's not going to be an interval. anywhere where my derivative is equal to 0. So that looks like right there and right there. So at x equals -2 and 2, because f prime of x is equal to 0. Or you could say, if you're talking about the graph, f prime of x has x-intercepts at those spots. At what values of x does the graph have a relative maximum? So we're going to say f of x. So it's going to be at one of these, right? If it has one, it's going to be at one of those values. F of x has a relative maximum, because the relative max is wherever you have a horizontal tangent line and it switches from, the function switches from increasing decreasing, which means the derivative would switch from positive to negative. So f of x has relative max at x equals, so I'm trying to look at those two zeros and see where it switches from above the axis to below the axis as I move through the 0 from left to right. So I have a maximum at -2. Because f prime of x switches from positive to negative. There's a bunch of different ways I could say that. I could also say because it switches from, f prime of x is bigger than 0, that means positive. I just like to keep pointing that out, to f prime of x being less than 0, which means negative. Or you could say f prime of x switches from above the x-axis to below the x-axis. At what values of x does the graph have a relative minimum? So that's going to be when it changes from the vice versa, from when the derivative changes from negative to positive. So we're going to say f of x has, let's take a look at this graph. The only other 0 is here, and the derivative as we approach, as we kind of move through that 0, that horizontal tangent line, or that derivative of 0, is negative, and it remains negative. So it never switches from negative to positive. So we're going to say f of x has no relative minimums because f prime of x never, switches from negative to positive at any x value. What's the slope of the normal line to the graph of f of x at x equals 4? So I'll kind of do it at the end. I'm not going to state the answer right away because it's going to take a little bit of work. So at x equals 4, we have the graph of the derivative. At x equals 4, the derivative is -2. So we know that f prime of 4 equals -2. What does that mean in words? This means the slope, because derivative means the slope of the tangent line, right? So the slope of the tangent line, okay, at x equals 4 is -2. So the slope of the normal line which is perpendicular, I'm going to abbreviate there, to the tangent line at the point of tangency is the opposite reciprocal. So the slope Here's my restatement of the question of the normal line at x equals 4 is 1/2. Okay, let's look at the next thing. Let's see, is this our final? Yeah, okay, last page. 2 problems. For each of the given functions, determine the interval on which f of x is increasing and or decreasing. Find all coordinates of the relative extrema. Unless otherwise noted, perform the analysis on all values from -infinity to infinity. Provide justification for your answers. Okay, this is why you have a lot of space here. So they're telling us f of x, but they want to know about f prime of x without looking at the graph. When is it increasing? When is it decreasing? So in order to get that information, the fastest way is to apply a power rule and find my derivative. They want to know when f is increasing. Well, it's easier to find out when a function is positive or negative. That means it's either above 0 or below 0. So what we're going to do is take the derivative, set it equal to 0, and then solve for x. So we're going to do what here? Common factor, 15 x squared times x squared minus 1. 0 equals 15x squared times x plus 1 times x minus 1. So we can make each factor equal to 0 and solve. That's how we find the zeros. So I get x equals 0, x equals -1, and x equals 1. So those are the x values for which my derivative is 0. So what we're going to do is we're going to make a test interval. I'll label that f prime of x. We're going to talk about the derivative on this interval. And then from all that information, we can then talk about what happens with f. So I'm going to first put in here where the derivative equals 0. I have to put them in alphabetical order, so 0 would not go first. All right, so now what I'm going to do is I know the derivative at these spots is 0. So I have a horizontal tangent line at those spots. Now, that means there's a possibility that the derivative switches from positive to negative. So on this interval, -infinity to -1, all of those x's have the same derivative, meaning they not the same number, but the same sign. They're all positive or they're all negative. Because if they were going to switch, it would have shown up here as a 0. Since these are the only zeros, those are the only possible spots where it could switch. So we're going to pick an x value off of this interval. I'll say like x equals -5. And I'm going to put it into the derivative to see if I get a positive or a negative derivative. So I'm going to say f prime, oh, and by the way, down here I should probably say f prime of -1 equals 0. Because I actually evaluated it. F of 0 equals 0. Sorry, f prime of 0 equals 0. And f prime of 1 equals 0. Now, on this guy, we're doing f prime of -5, and I want to find out if it's positive or negative. So I'm going to test it up here in my derivative. I like factored form because I can just figure out if what the signs are. So if I put a -5 in this first term, it comes out to be positive. If I put a -5 in the second term, it becomes negative. If I put a -5 in there, it's also negative. So I get a positive times a negative is a positive. Now we're going to pick a number on this interval. I'm going to say -1/2. And I'm going to test the derivative. F prime of -1/2, find out if it's positive or negative. So now I'm going to do that same analysis. If I put in a -1/2, 15x squared is going to be positive. That one's always going to be positive, right? This one, if I put in a -1/2 plus 1 is positive. And if I put in a -1/2 there, I get a negative. So here I'm going to get that this is a negative derivative. Sorry if I'm squishing that in there. That's negative. Now I'm going to pick a value here, x equals 1/2. and test the derivative again. So I'm going to say f prime of 1/2 equals, if I put in 1/2, I always get a positive on the first guy. On x plus 1, I get a positive, and on that last one, I get a negative. So I get negative. And then on the last one, I'll say x equals 5. I'm going to get a positive times a positive times a positive. So f prime of 5 is positive. So with that information now, I can answer some of the questions. So I want to restate all the questions. It said, determine the intervals on which f of x is increasing or decreasing. So this is all information about f prime of x. Keep that in mind. So I'm going to say f of x is increasing on the intervals -infinity to -5, and then union 5 to infinity, because f prime of x is bigger than 0 on these intervals. F of x is decreasing on, and I'm going to say, let's see, it's decreasing from -1 to 0, union 0, to, where am I? 1, sorry. So f of x is decreasing on that interval because f prime of x is less than 0 on these intervals. We're going to talk about these intervals. There's another option here. Like, you could look at it a different way, but I want to talk about that in class. So I'm going to talk about this part here, so you can remind me to bring that up if I forget. But we'll come across it anyway, so in our practice. Now we want to talk about if it has any relative maximums or minimums. So f of x has a relative maximum at x equals, looks like -1, because f prime of x switches from positive to negative. Right, so I'm looking up here, I see a switch from positive to negative, and that's the only time I see that switch. That occurs at -1. F of x has a relative minimum at, we're looking for a switch from negative to positive. That occurs right here at x equals 1, because f prime of x switches from negative to positive. Did they ask for anything else? Nope. And I gave the justification, so we're good to go. Let's look at this last one. So same thing, we have questions about f when it's increasing, when it's decreasing. So now we're going to have to take the derivative of this function to answer those. And remember, we're doing it on this interval 0 to 2 pi. Because this thing repeats, I'd have infinite maxes and mins. Because this is a cyclical function. So when I took the derivative of sine, remember that 2 comes along for the ride as a coefficient. The derivative rule for sine is cosine. I set it equal to 0 and solve. So I'm going to subtract 1, divide by 2, and I'll get -1/2 equals cosine of theta. So we're looking for what angle has a cosine value of negative 1/2 on the interval 0 to 2 pi. So a negative cosine value is going to be in quadrants 2 and 3. So it looks like it's going to be, I think, 5 pi over 6 and 7 pi over 6 or something like that. Let me think. Oh, no, 1/2 is the short one. So it's going to be 2 pi over 3 and 4 pi over 3. Yeah. So theta is going to be 2 pi over 3 and 4 pi over 3. If you're doing like actual, that's just thinking through the problem. If you're going to use your calculator, you can inverse cosine both sides. That's how you solve when theta is inside of a cosine. So the inverse cosine of cosine, they cancel each other out because they're inverse operations. The inverse cosine of negative 1/2, your calculator would report back those values. And it's just, the inverse cosine just means what's the angle whose cosine value is negative 1/2, which we just talked through. So these are the ones that are on the 0 to 2 pi. By the time we come back around to it again, as we go through the unit circle, we would go outside of our domain from 0 to 2 pi. So those are the only two. So we're going to make our test interval. This time it doesn't have arrows at the end. And this is going to be f prime of theta that we're talking about. All this information starts at 0, ends at 2 pi. We've got 2 pi over 3 and 4 pi over 3. And at those values, f prime of 2 pi over 3 equals 0. F prime of 4 pi over 3 equals 0. Now we got to test each interval. So we can pick an x value, I'm going to say, or a theta value. I'm going to choose pi over 2 from that interval, and I'm going to plug that into the derivative. So let's see. I'll probably just use this one here and find out if it's positive or negative. So the cosine of pi over 2 is 0. 1 plus 0 is positive. So we're getting a positive. Now we're going to do f prime of, we got to pick a value in here. We're going to do pi. So if I plug pi in here, cosine of pi is negative 1 times 2 is negative 2 plus 1. So I'm getting a negative value for my derivative. And then on this interval, we're going to choose 3 pi over 2, because we got 4 pi over 3. So yeah, 3 pi over 2. So f prime of 3 pi over 2 is going to come out to be positive, because the cosine value at 3 pi over 2 is going to be 0 again, and so you get the 1 plus the 0. So now I have all my information about f prime. I can make my statements like I did over here about f of theta. So f of theta is increasing on, and you can make these statements, and so pause the video and see if you got them right. And actually, I'll put them up to start class and we'll check them in class. So we're done.